Okay, hello everyone, and thank you for logging in to today's session. My name is Michael Downey, and I'd like to welcome you to today's webinar. The topic for the session is pre-fermentative addition of water or low alcohol wine into juice to manage alcohol levels of wine. Now, to tell us more about this topic, we're fortunate to have with us Olaf Shaleski from the University of Adelaide and the ARC Training Centre for Innovative Wine Production. Olaf began his career studying viticulture and oenology at the University of Geisenheim, Germany, followed by a Masters of Science in viticulture and oenology in France and Spain. After 6 vintages working in, among other places, Bordeaux, Madrid and Moselle, Olaf joined the ARC's Training Centre of Innovative Wine Production at the University of Adelaide in 2014 to start a PhD looking at strategies to manage the alcohol content of wines. His project and the topic for today's webinar investigates the implications of pre-fermentative juice substitution with water or low alcohol wine on the final quality of Cabernet Sauvignon and Shiraz wines. Now, before we get started, some quick housekeeping. The format for today's session is a short PowerPoint style presentation followed by a Q&A. If you'd like to join the conversation, please type into the questions pane of your control panel in the bottom right corner of your screen. For those with access to a microphone audio that's dialed in, there is also the option of speaking directly with our presenter by clicking the raise hand button. This is located near the top left section of your control panel. Questions will be asked at the end of the session, but please feel free to send through your questions at any stage. If you'd like to get involved through Twitter, please use the Twitter handle @the_AWRI. The webinar is being recorded and will be available to view later this afternoon from the AWRI's YouTube channel. Now, before we begin, I'd also like to acknowledge and thank Wine Australia for providing funding and support for AWRI webinars. Okay, that's enough from me for now. I'm going to hand over to Olaf to help get us started.
Hello everybody from my side. Thanks for logging in to today's webinar, dealing with water into wine. And I would like to jump straight into the background of this PhD topic of mine, actually, that I've been dealing with for the last 3 years, and for which I would like to, actually, I'm really happy to share some key findings with you today. And the catchphrase actually for me would be the compressed vintages, which is which includes actually 2 main effects which we are dealing here in the background of climate change. So one is increasing temperatures during the ripening period or throughout the vegetation period. They lead to an earlier onset of ripening, which shifts the sensitive part of the berry ripening or grape ripening into a hotter part of the year, which then again is more and more characterized with unpredictable extreme weather events like heat waves and drought, again coming up more and more actually in a higher frequency. Which in the end then causes berry dehydration and berry shrivel. And this causes what I call it overlapping harvest dates, where crop or grapes across different vineyards or grapes across different cultivars even need to be harvested at a very short time frame or even at the same time. For example, Cabernet Sauvignon and Shiraz, what I've been observing here quite often. And there's obviously a limit what the winery can take up. So some of the fruit is just exposed to overripeness in the vineyard. And the consequences are more frequent, what we observe, sluggish fermentations with the final wines being associated with an overripe aroma profile, if not hotness. And yeah, for the nature of this this problem, let's say problem frame, which is unpredictable. Yeah, the unpredictable nature of these heat waves and weather events. We need flexible and easy to adapt solutions with, again, yeah, minimum input, if possible, pre-fermentative application. Yeah, to avoid any negative implication on the quality if possible, to manage these, yeah, let's say aroma profiles, or at least the excessive alcohol contents. So what has been suggested previously is yeah, replacing the high alcohol juice with low or non-alcoholic blending material. So the topic given to me back then was already defined by Kontodakis in his paper in 2011. So the use of unripe grapes harvested during cluster thinning as a method for reducing alcohol content and pH of wine. So this basically targeted two things. One is to reduce waste, vineyard waste, and so after cluster thinning, instead of throwing those grapes away, taking them up, making wine out of it, and including it into the production, which yeah, could increase potentially the profit, and the natural acidity which comes with it to regulate the pH of wine. So my project was to investigate further and see, yeah, limits of this method, trying out different varieties, different vintage conditions. But I was particularly back then already interested to compare this with water blendings. So just to have, if you will, a second control to this. And particularly because I knew that it's kind of a topic in the winery or in the wine business. It's everyday bread. I think this the problems with the high alcohol and the availability of water in the winery. And lucky enough, today it is actually up to date, again after the approval by the Food Standards Australia and New Zealand, which allows actually the water dilution down to 13.5 ppm. So there we go. What I did, I would like to describe you a little bit the method, the experimental setup. So I would start with the very first harvest around Veraison to obtain the material for my green harvest blending material, or blending wine, which I call how I call it, sourced from McLaren Vale. It was Cabernet Sauvignon. And my second main harvest focus was a commercial harvest at one stage, ideally a little bit higher in alcohol. And the consecutive harvests, H1 and H3, what you just see here, I included them because I was yeah, just interested to compare, let's say, alcohol managed wine through those blending trials. With wines with similar alcohol content, but just from earlier harvested grapes. So let's say a third control into that, and to have a bigger picture in the end with my results. So the green harvest wines, the grapes were picked, they were crushed, and normal white wine making was conducted, which led up, gave me a wine of around 4.5 to 5% alcohol and a pH of incredibly 2.6, so very low, and it's not nice to drink. But for that reason also I used charcoal, so I heavily fined this wine with charcoal to remove any negative green aroma characters, which then later could ruin the product itself. Then the last harvest point, which was the commercial harvest, and then hence my control as well, was crushed, or the grapes were crushed, and I took out or bled out a proportion of the juice and replaced it either with the green harvest wine or with water in 3 different levels. So to achieve or to yield in the end wines with 3 different alcohol levels, but out of 2 different blending partners. important here is that the solid to liquid ratio is constant throughout those blendings. Yeah, so in the end, I ended up with, yeah, as I said, 3 different alcohol levels plus the control wine of the main harvest. And so these codes, what you see here now, B1 to B3, they stand for the green harvest wine addition treatments, and the BW1 to BW3, they stand for the water additions. And those, so just so you know, those codes will be consistent throughout the presentation. Okay, my results, 2015, my first vintage. So the vintage overview, the vintage conditions were basically exactly as I described them before in the introduction. So we had a very early year, which shifted a sensitive part of the berry ripening into quite a hot part of the year, which again was characterized by heat waves, which put a lot of pressure on the vine, again connected to drought, so low water availability, which ended up, which resulted in a commercial harvest to be at 30.5 brix. And when you have a look at the left hand side, the table here gives you a little bit of overview when you just focus first on those reddish colors. So this, the very dark red would be the control, the last harvest point, with 18.2% alcohol in the final wine. And the one previous harvest, so within 4 days, the alcohol increased basically by 3%. And there was a problem, there was not enough time to react. There was a weekend in between, and yeah, the winery ended up basically with this crop. And now the subsequent parts of the tables here, so the green color-coded part are again the green harvest wines, and the blue-coded are the water blending wines. And you see here the substitution rate. So for the same alcohol level, I obviously needed to incorporate a little bit more of the green harvest wine, as it has itself a little bit of alcohol already. Further, what you can see that there was a, as expected, a pH decrease with increasing incorporation of the green harvest wine, whereas with water, the pH stayed constant. So having all these wines, I conducted chemical analysis. So I was interested in the composition, in non-volatile and volatile composition, and also in the sensory later on. And so the findings were actually quite interesting and stunning to me, because the blendings, the blending treatments did not cause any changes to anthocyanins, to the color intensity, to the total phenolics, not to the total tannin concentrations. Further on, going deeper in the tannin composition, the molecular mass remained the same, steady. Polysaccharides also did not decrease, they even partially increased in some of the blending treatments. So out of these values, what I got, I would first expect, or let's say predict maybe, that there's no negative implication in the end on the sensory from that point of view. Then further, as we're dealing with Cabernet Sauvignon, I was interested to see what happens with the methoxypyrazine concentration, as it is yeah, one of the main driver for green yeah, aroma perception of these wines. And here on the left hand side you see that I would like to show you that graph, which shows you the different wines, so the consecutive harvest wines, the control and the blending wines. And here the green bar, the H0, this is the green harvest wine, so the blending material which I used. And after all this charcoal fining, there is not much of pyrazines left. It is definitely under the obvious green aroma threshold, and so it did not negatively impact or could not possibly negatively impact the blending wines in that deal. So it could not increase the IBMP concentration there. And indeed, it didn't really change except for one treatment where I had a little bit out of normal behavior. All the other blending treatments remained similar to the control and under the obvious green aroma threshold. Besides from this varietal volatile and also a couple of others, the majority of fermentative volatiles also did not change significantly towards the control. And I didn't see any, I could not detect any dramas there, which would say like there's a absolutely loss in quality. And last but not least, I could not detect any apparent effect on aging. Some of the main quality parameter analysis I performed after 18 months, and all the blending treatments did not perform worse or better than control. They basically behaved similarly in terms of aging, in terms of color development. Now going to the sensory analysis. Here, most of all of the things actually what I just indicated from the chemical point of view could be confirmed by the sensory. So the blending did not cause significant changes in astringency, bitterness, aroma intensity, red and dark fruit, or green attributes. The only thing what was interesting for me was that hotness, or the hotness perception, actually sustained, even if the blended wines were lower in alcohol than a wine which was just made of grapes picked earlier, in that case H3. So we had here still a big difference in hotness perception, meaning that hotness in the end was not only driven by alcohol itself, but also by probably changes somewhere in the matrix of the composition of the wine. So we had another view, actually, another avenue to target the problem of berry shrivel and hotness and higher alcohol through my side project, which dealt with berry ripening heterogeneity, which I would like to just put here in, very briefly. So I had a chance to take berry samples of each of the harvest dates what I had, so 1,000 berries per harvest dates, and measure their size and the respective Brix, so sugar content of the berry, and those two values were always linked for the berry, which gave me the opportunity to, in the end, show the berry size distribution, for example, here on the left-hand side in that graph. And the interesting part is the tail on the left-hand side of that graph, where you can see from the first harvest point, the blue line, until the last harvest point, the yellow line, we have a increase in small berries, which basically indicates here the shrivel and the over-ripeness, what is happening. I translated all this data, what I got from, into this a bit compact table on the right-hand side, which I just would need to explain briefly. So you can see 3 color codings, which basically stand for 3 different berry sizes. So a large berry size category, a medium berry size category, and a small berry size category. And for the first harvest date, for instance, there were 83% of the crop were medium-sized berries with an average of 21 Brix. 3.2% of the total crop at the first harvest were small berries, and around 14% were actually quite large berries still, with an average of 21 Brix. Now going to the last harvest point, the H4, you can see that almost all large berries disappeared. Medium-sized berries almost stayed constant as well, but we have 10% of small berries in the crop, which are characterized with a Brix of more than 35 Brix. And more than 35 means we got here, there were some of them I couldn't measure anymore because they were basically raisins. and hence very high in sugar content, and then they are likely to influence in the end or drive the high alcohol content and drive the hotness perception. So knowing this out of this data, it could be an alternative way to target this overripe tail and get rid of the berries and just remain with the medium and large berry sizes here to manage the alcohol level. Or alternatively, if it would have been possible, going to H3, harvest at that point, getting rid of these 6% of the small berries, and yeah, also managing the alcohol level a little bit and achieving another wine style. So there are like some other solutions which are possible and thinkable through berry sorting and through the assessment of ripening heterogeneity. All right. In 2016, I repeated the experimental design, what I just presented to you in 2015 wines regarding the blendings. But in addition, I put Shiraz on the menu. And so the vintage conditions in 2016 were different. So the total soluble solids were plateauing without or only a little berry shriveling. We had, it was a very relatively early vintage as well, but without any compression, without signs of, let's say, stress in the winery, stress in the viticulture people. So it was kind of a smooth vintage with no excessive alcohol content. So a contrast program, which is perfect for to see what happens if you have different conditions. So again, the findings of the 2015, I was happy to see that they could be confirmed. So the blending did again not change any causes in anthocyanids, color density. I even could detect slightly higher values in color density among the blending treatments than in the control. Total phenolics did not change again. Total tannins also did not change significantly to the control, and the water blendings, for instance, even performed better there and showed slightly higher tannin values. And no apparent effect on aging was detected, could be detected. What was interesting though, that in the smooth vintage conditions, I found more of a separation between the liquid use. So either if it's water or if it's the early harvest wine, the green harvest wine, where in this case the water blendings performed better in stable pigments and were higher in tannins actually than the green harvest blends. Sensory, again, there were no shocking moments for me. So again, no significant changes in astringency and bitterness, aroma intensity, red and dark fruit and green. What was interesting this time that the hotness did not sustain, so it was less apparent once the wine was one of the blendings basically compared to the control. So a little bit of reduction of hotness was this time possible. In Shiraz, no changes again in the color parameters nor in the total tannins compared to the control, but lower this time for the Shiraz variety. Lower levels of stable pigments for both methods actually, so for the green harvest blending or the water blendings compared to the control was detected. Also straight after buttering, the color intensity was lower than the control in all the blending treatments, which even out after aging again. But yeah, this time in the Shiraz variety, the difference caused by the type of blending liquid was more obvious. So I see there a little bit a different behavior according to the variety used. And also this time in the Shiraz example, it seems that the water blending performed better with a higher level of stable pigments in the end, and with a higher value actually of tannins compared to the green harvest. And what I can show you about the Shiraz in terms of sensory, similar findings to the Cabernet. So again, no significant changes in the main attributes. Again, this time the hotness was less apparent in the blended treatment than it was in the 2015. So in 2017, after the findings of 2015 and 16, I decided to ditch the green harvest blending and just concentrate and focus on the water water blending treatments and water additions to manage alcohol levels, particularly because it became up to date with the regulation changes. And I decided to push it to the limits in terms of the substitution and the dilutions this time, because I've been more interested in the effects on the extraction from tannin from grape composition, so tannins, polysaccharides, and potentially volatiles. So I had a little bit of different experimental setup. I'm just using water and I'm comparing dilution and substitution. So one time I'm keeping the blending, the liquid to solid ratio constant, and on the other part I increase severely the liquid phase during the ferments. In addition, I was also interested on how harvest time actually impacts the suitability of blending to manage alcohol of wines. And for this I orientated myself along the concept, or the ripening aroma concept of Alain Delois, and I picked at a fresh fruit and a mature fruit stage in 2017. And yeah, I concentrated this time only on Shiraz. And in 2017, the vintage conditions were again a little bit different, so a very late vintage, but no berry shrivel and moderate alcohol levels again. And so far, this research, as you can imagine, I just bottled the wines 3-4 weeks ago. It's still under construction. It's foregoing, and I will have, I think, towards the end of the year, all the compositional results plus a sensory assessment coming up. But I wanted to share with you some first impressions that I found during the last 3 weeks when I had the first look at some of the quality parameters. No surprises actually for me. The color parameters were retained higher in the substitution as opposed to the dilution. The same was actually seen in tannins, so we had always a little bit of a superior performance of the substitution of the wines than in the pure dilution. But harvest date seems to have an impact here. So the severe difference between those two treatments was more obvious in the mature fruit stage than it was in the fresh fruit stage. And the last bit, last comment on the right table here, where you can see the control, again red coded with 15.5%, and then the substitution treatment with 14.5% and the dilution treatment with 14.5%. So in this area of this level of alcohol management, only a little percent or 1% change. There was no obvious advantage of the substitution so far, what I could see, towards the dilution. And also, like anecdotal, I've tried those wines already. It's not very obvious, so things need to be still confirmed. But it seems that in that case, to that alcohol content, it could have been just easier to just dilute, add water without significantly changing the quality in the end. All right. I hope I'm not over time yet. So jumping into the conclusions, it could be basically mission accomplished, easy to adapt and low input could be confirmed of that of the treatment of both of the green harvest wine treatments or the water treatments. They both seems like suitable to manage the alcohol content of the wines. No adverse effects on quality parameters could be seen, particularly again for blendings, let's say down to 13.5 Bormeo, or adjustments down to 13.5 Bormeo in that area. Absence of dilution effects in aroma, but as we've seen in 2016, lowering of the hotness perception. No appearance or increase of any negative aroma attributes. And what I think is interesting and what pushed me to the 2017 trial is that water is actually as good as green harvest wine to manage these alcohol levels. Given that water is more available or easier available maybe than the green harvest wine, I think everybody else needs to be judged again on a single case, I guess. Sorry for that. And again, for small alcohol adjustments, dilution could be considered for similar quality but higher yields, and I leave it still in a question mark because this is under investigation at the moment, and I'm really happy to share my findings once I have it towards the end of this year. And I also have written again berry sorting, just to remind you on that slide that I had before regarding berry heterogeneity and sorting options. There's certainly still some more research necessary, and I think also ongoing, to optimize the availability, basically, but to optimize the availability of data and basically synchronizing it to machines and to harvest decisions and so on. But so far my findings of that site research shows that this is could be certainly promising as an alternative to target or to manage let's say extreme high alcohol crops, etc. For the blending treatments, winery trials are certainly recommended still to suit wine styles, maybe different cultivars, then implementation of malolactic fermentation in barrels, so like going away from experimental winemaking and starting making real wine. And at that stage I would like also to refer to two of my colleagues that have been working on projects that actually complement that the approach of managing high alcohol contents through earlier harvest or through diluting. Anna Hranilovic, she has been working on non-Saccharomyces starter cultures to boost aroma flavors, and additions of minor proteins or tannins have been investigated by Xijing. Both treatments or both ways could certainly address some shortcomings that might come out of dilution treatments. All right, so from my point, that was the last slide. Thank you very much. And I think I get back to Michael. Before I forget that, my acknowledgement to everybody who has been supporting me during the last almost 3 years. Yeah, looking forward for the future last 1 year to go. And yeah, thanks everybody.
Okay, thank you very much, Olaf. We'll move here straight into a Q&A. We've already received one question, and I'll open up to everyone else who's got any questions. Please start sending them through now. Just a reminder, if you do want to ask a question, there are a couple of ways you can do so. You can type it into the questions section of your control panel, or click the raise hand button and I'll unmute your mic and you can chat directly with Olaf. So the first question we've got here, Olaf, was in relation to the 2015 results that you were discussing, but it may be applicable across all your results. It comes from Paul, and he's asked, pH stayed constant for the water wines, but what about total acidity?
Hello, Paul. So the total acidity obviously dropped partially in the wines. So it is necessary in the end it was necessary in the end for me to adjust the acidity and total acidity actually to get back to normal values.
Okay, great. Thank you for that. Hopefully that's answered your question there, Paul, but if you did have any other follow-ups regarding total acidity, please send them through. We don't have any other questions for now. We'll hang around for another 30 seconds or so and see if any more come through. This is the final AWRI webinar for the 2016-17 program. So we don't have any details exactly about the start date for the new program. That will be released shortly, looking at this stage to begin in July, but yeah, stay tuned to find out more about that. Looks like that's going to be it with regard to the Q&A, Olaf. Did you have any final comments that you wanted to make?
Yeah, so as there are no Q&As at the moment, I'm really happy to receive emails for further questions later on, and I'm really open for discussions and input from the side of the industry. So yeah, please don't hesitate writing me emails, and I'm happy to address any questions afterwards anytime from my side. Thank you very much.
Yeah, great. Thanks for that, Olaf. Yeah, as he's indicated, if you do have any questions, you can contact Olaf directly, or if you want to send them through to the AWRI, I'll make sure he sees your questions. Attendees will receive a follow-up email with a link to the recording of this session. There'll also be a link to a survey. As I mentioned, that was the last AWRI webinar for this year's program. Stay tuned for next year's program. So that's all we have for today. Thank you again for attending, and I look forward to seeing you again at the next AWRI webinar.